This is slope 5. We're going to go over the solutions. So this is qualitative interpretation of graphs, of the slopes of different lines. So we're not given numbers, we're just asked some questions. We're given a sketch of a graph, we're asked some questions about it. Which line has a positive slope? Number 1 says which has a positive slope, and how do you know? And we can see that B has a positive slope. The line is going up. And if you gave me that answer, that would be fine with me. Even though, hopefully you can look at this and see that both of these lines are plotted below the horizontal axis, which means that their y values, or their vertical axis values, are all going to be negative. But remember, slope is not about where the line is, it's about where the line is going. So we can see that B is going up, it's becoming less negative, and so it therefore has a positive slope. Question 2, which has the slope with the greater magnitude, and how do you know? Magnitude just means how big is the number. And we can see that line A would have a steeper slope. If I did have numbers here and I calculated them, hopefully you can see that A would have the bigger slope. If we go back to that analogy where we thought about these as hills you might be sledding down, on hill A, you would get a good ride. You'd pick up some good speed compared to hill B because A is steeper. If that analysis doesn't do it for you, we can also look at it a little more analytically, and we can see, well, they both end up crossing. These lines end up crossing at this point here. Oops, let me go straight up from here. And we can call this point X. If we want, we can call it whatever we want, but we'll call it X. And we know that they both started at 0. So in this interval from 0 to X, both of these lines, A and B, traveled some distance along the vertical axis. And let's look at what A did. A started here, and it ended up here in this interval of X. So this is where line A started initially. This is where it ended up. And again, during this interval X, how far did it travel along the vertical axis? I'm just going to color it in. It traveled that distance down the vertical axis from here to here. So it went from this y point to this y point, and this would be the y distance over this interval X. What about line B? Line B started here, and in this interval X, it ended up here. It ended up in the same place that line A did. What distance would that be along the vertical axis in this interval X? This distance. And we can see that this would be the change in y for line B. And we can see that this would be the change in y for line A. And hopefully you can see, looking at this, that the change in y for A, and we'll just put absolute value there so we know that we're not taking direction into consideration. Hopefully you can see that that is bigger than the change in y for B. So again, in the same interval X, you have a bigger change in y for line A than for line B. How does that translate in terms of slope? Well, we can say that the slope, we know, is change in y over change in x. We know that change in x is the same for both of these lines. From the beginning of this event to whenever they intersect, we know that the change in x is the same, but we also know that the change in y for A in that interval X is greater than the change in y for B in that interval X. These denominators would be the same. Therefore, the slope of A is greater than the slope of B. This kind of analysis we're going to do later on. So if you understand that, or if you can go over this and get a sense of what I'm talking about, that would be great. If not, you'll see it again. But for this, for number 2, if you just said A has the greater slope because it's steeper, that would be wonderful. So here's a new graph, and you're asked in number 3, when the lines cross at x equals t, what can we conclude about them? Can we conclude, choice A says they both have the same slope, and no, we can't conclude that. Why can't we conclude that? Because I know that line A has a positive slope and line B has a negative slope, and this is for the whole graph. Choice A doesn't say they have the same magnitude. Their slopes have the same magnitude. It just says that they are the same, and they're not. A will be positive, B will be negative. So A is right out. Choice B, both lines have the same y value when x equals t. Well, they do. At this point here, their x value, in fact, they have the same x and y values. Their x value is t, whatever that means, whatever that is, right? I told you that it's t. And if I go across to this vertical axis, the y value is 0. And so that is true. They both have the same y value. It happens to be 0 in this case. So that's true. Both of the above is right out because A is wrong. So the answer to 3 is B. Let's take a look at number 4. If the slope of line A is 2, then what is the slope of line B? And how do you know? Well, the slope of line A, I'm told, is 2. There are no numbers here, but is there any way that I can figure out the slope of line B? And there is. This starts, line B starts at positive y, and after some interval t, it ends up at 0. Line A starts at negative y, and after that same interval t, it also ends up at 0. And so they both traveled. Their delta y was y. The delta y for A is going to be y2 minus y1. And y2 is that second point. y1 is that first point. So the delta y for A is going to be y. What is the delta y for B? It's just going to be y2 minus y1 for B. y2 is 0, right? After t seconds, it ends up at 0. y1, where does line B start? Well, it starts at y minus y, and this is going to be negative y. And I know that t is the same for both of them. So what is this telling me? It's telling me they have the same vertical change, the same delta y. It's just that B's the same magnitude of the delta y. It's just that B's is negative. B goes down, A goes up. B goes down y units, A goes up y units, all in the same, with the same delta x. So therefore, if A is positive 2, what must B be? It is negative 2. If this messes you up, and I would know this because the slopes have the same magnitude. So the answer is negative 2. Slopes have the same magnitude. If this messes you up, dealing with these t's and these y's and dealing with things that aren't numbers, there is nothing in the world stopping you from putting numbers into here. So let's say that this is 2. That would make this negative 2. And let's say that this is 1. So again, instead of y and negative y, I'm just going to call this 2 and negative 2. Instead of t, I'll call this 1. I can say, well, the slope of A is going to be change in y over change in x. For line A, that goes from here to here, for line A, the change in y, well, it goes up 2 units and 1 with a delta x of 1. So that would be 2. I could say the slope of B, same thing, delta y over delta x. In the case of B, it went down 2 on the y-axis and across 1 on the x, so it would be negative 2. So if you don't like dealing with just variables, and a lot of students don't, you can just use that strategy by actually putting numbers in there. Here's number 5. You're told the lines are parallel, and hopefully we know that that means they have the same slope. So let's look at our choices here. The slope of line A differs from that of line B in that A begins with a positive slope and gets a negative slope, but B has a negative slope for the whole graph. I'm trying to find out here if you understand that where this starts, just because this started, where the y values or the vertical axis values are positive, right? Here's the x-axis, here's 0. This is where all the positive numbers are. This is where the negative numbers are. In choice A, which is wrong, I'm trying to see if you understand that where the points are plotted has nothing to do with the slope. So just because this starts out with positive values for y until it crosses this axis here, it doesn't mean it has a positive slope. It is going down, so this has a negative slope the whole time. So choice A is wrong. A has a greater slope than B because A is always above B. Slope has nothing to do with the position of this thing on the y-axis. It just has to do with how does y change divided by how does x change. So this is wrong also. There is no difference in slope. Lines A or B are parallel, and parallel lines always have the same slope. That's the right answer. So again, dealing with just graphs with lines on them, you may be able to answer this, but when we start putting different dimensions here on the horizontal axis and vertical axis, these are the kinds of questions that students get wrong. So just know that if they're parallel, the slope is the same. All right, number 6, line B is horizontal. What is its slope? How do you know? What is its slope? Its slope is 0. Because delta y is 0. There is no change. And we know slope is delta y over delta x, and delta x is changing. It's, trucking along here. It's getting larger and larger as it goes from left to right. But 0 over any number is 0. So I know that the slope of that line is 0. Number 7, what relationship does line B show between the variable on the horizontal axis and the variable on the vertical axis? So this is saying as I change whatever this variable is on the horizontal axis, what happens to the values along the vertical axis? And there is no relationship. That's what a horizontal line shows, that there's no relationship between the horizontal axis variable and the vertical axis variable. As the x-axis variable goes up, y values do not change. So there is no relationship. Number 8, when x equals t, what can be concluded about lines A and B? And this is trying to trick you into saying they have the same slope at that instant. They don't. A has some positive slope, this entire graph, and B has a 0 slope, this entire graph. So at t, lines A and B have the same vertical axis value. And that's all that tells me. So at this point here, whatever this y value is, B has that y value, A has that y value. At this point, both of them would have this coordinate pair where the horizontal value is t and the vertical value is y. And that's all that tells you.